My name is Reagan Cole, and this is my video lab for experiment 6, chemical equilibriums. So I have the equations written behind me, but Screencastify flipped them, and I don't know how to reverse that. So I will be reading them off. They are written on the board behind me. So I'm doing part A, part D, and part F. So the equation for part A is CH3COOH aqueous yields CH3COO minus aqueous plus H plus aqueous. So, um, part A said to explain the significance of the first pH measurement. So the significance of the first pH measured was to provide a base to compare our findings to. So if we knew the original pH compared to what the pH changed to after the reaction occurred, we could compare it, and this could tell us what the stress was, if the equilibrium shifted left or right, and why this happened. So the original pH with the acetic acid was 4.5, but with the sodium acetate, which was our stress in this solution, when the sodium acetate was added, it changed the pH to a 6. So by increasing the pH with the stress of adding the sodium acetate solution, there's an increase in the hydroxide ions. From Le Chatelier's principle, this causes the equilibrium to counteract, meaning it shifts back towards the reaction, so it shifts left. And that's all I had for part A. Part D was cobalt/cobalt chloride equilibrium. So the first part was, what color is COH2O6 plus 2 ion? That was pink, and COCl2 minus, that ion right here is blue. So this is the pink one, this is the blue one. So the next part was explain the color change that occurs when hydrochloric acid was added. So in this part of the reaction, hydrochloric acid was the stress, and when adding the hydrochloric acid, the reaction turned blue. So this is a shift to the right or towards the product side. And our observation supported this with the equation because the ion COCl4 2 minus is blue. So when adding that stressor, Le Chatelier said it would shift right. And since this is the blue side, it supported that because it moved in the same direction. The next part was explain the color change that occurred when heat was added or removed. So I'll start with heat was added. So when heat was added, this was our stress. So when the heat was added, the solution turned a darker shade of blue. This meant that there was a higher presence of COCl4 2 minus ion because it was a deeper, darker shade of blue. So Le Chatelier stated that this is a shift to the right or to the product side. He also stated that when temperatures increase, there's a shift to the right, and therefore the reaction is endothermic. So our observations also supported this because originally it did shift to the right and it became more blue, and we know that this supports Le Chatelier's principle because COCl4 2 minus is the blue side versus when heat was removed. So the next part was when heat was removed. So when this happened, it turned a lighter shade of purple, like almost like a violet, almost pink, which was a shift back to the left, meaning that there was a higher presence of COH2O6 2 plus. So we already know this is an endothermic reaction, and Le Chatelier stated that when heat is removed from an endothermic reaction, it shifts back to the left, and our observation supported this because when the heat was removed, it turned a lighter shade of pink, meaning it shifted back to the left, which Le Chatelier said would happen. So our observations supported this principle. The next part was, is this reaction exothermic or endothermic? So based off of the first part, you could tell that heat was the reaction, or reactant. It was the reactant because it caused it to shift to the right, turning more blue. So this is in fact an endothermic reaction because heat was the reactant, like I said. It's endothermic because when there's an increase of heat, it shifts the reaction to the right, which we saw because it turned more blue. And when removal of heat is added, it shifted it back to the left, which was the pink side, which we also saw in our observation based off of Le Chatelier's principle, and our chemical equation. So that is how we know this reaction is endothermic. Finally, part F was the bicarbonate / carbon dioxide equilibrium reaction, and that was part F here. So the equation is HCO3 minus aqueous yields CO2 gas plus OH minus aqueous. So the first part was explain the chemical species that was removed by aspiration. So the stress that was being applied to this solution was attaching the vacuum aspirator, which removed the gas in the solution. In this particular reaction, the gas was CO2. So because the gas was removed, we observed the original solution, which was a yellow-greenish color, and it started to bubble once we added that aspirator. And this was because the gas was being removed from the solution. And then we also noticed a color change to a more light blue. So it changed from the greenish yellow to that light blue. Le Chatelier stated that this is a shift to the right because the solution turned to blue. And hydrochloric acid is blue, which we already knew. So this supported our equation supported this because we did see it shift to the right, which is the blue side, which we also saw in the reaction. So overall, our observations supported this because we saw a lighter shade of blue as the final product when CO2 was being removed.